Hello and welcome to Campbell, Shaffer and Company, and welcome to the neighborhood, neighbors. Here at Campbell and Shaffer, we provide many services to our clients. One of the questions that we're most frequently asked is, how exactly do you measure dry fertilizer? Well, today we have a video for you, and we're going to demonstrate and walk you through the details of measuring dry fertilizer. So sit back and relax, enjoy the show.
First, we will start with a line at the bottom of the paper indicating the floor. Next, we will start with the line on the left side of the paper indicating the back wall of the bin. Now this pile met the back wall, so we're going to start here, create our peak, and then come down to the floor. We'll then draw our three-dimensional part of the pile. Now I'm going to measure the width of the bin, 18 feet. The pile is 18 feet wide. Now I'll measure the distance from the front of the pile to the back of the wall. 16 feet. From the front of the pile to the back is 16 feet. Now I'm going to go up on the top of the pile and measure from the peak to the back of the wall. 6 feet. The distance from the peak to the wall is 6 feet. So first we'll draw a line down the pile. Distance from the peak to back wall is 6 feet. Now in this bin in particular, we actually have a point of reference on the wall. You might be able to see these black lines that kind of go across the bin. That's actually going to be 4 feet tall. So we have a line of reference. So if I climb back to the top of the pile, my line of reference in the pile gets about halfway up to that line of reference. So I've got about 2 feet to the back of the wall. The fertilizer came up the back wall at 2 feet. Now to measure the peak of the pile, as referenced earlier, we have the lines across the bin that are 4 feet tall. And as you can see, the peak of the pile is going to be roughly to that black line all the way across. So your peak's going to be about 4 feet. And the height of our peak was 4 feet. So now we can draw our shapes. We have a rectangle here, a triangle, and a triangle. This will be triangle A, triangle B, and rectangle C.
Alright, we have a density scale here. Another part of determining how much fertilizer you have in your bin is determining the density of the fertilizer that you have. Basically, you fill this cup full of fertilizer and you move the weight down the scale to determine how many pounds per cubic foot the density of the fertilizer. Alright, you want to make sure that you get the top of your fertilizer bucket completely flat. Then you're going to slide your scale down your density to get your weight until it balances on this ring. That looks like about 75 pounds per cubic foot.
Now we are ready to solve. We'll start with triangle A. Now we know the full distance is 16 feet, and the distance from the peak to the back wall is 6, so we should have 10 feet remaining for here. So we will take 10 times 4 times 18. And because this is a triangle, we will divide by 2. That is 360.
Then we will take that times 75. We now have 27,000 pounds in triangle A of the pile. Now we start with triangle B. We have the 6 feet, so we know this is 6 feet. So we know this is 6 feet times. Now the height of the peak was 4 feet, and we have 2 feet on the back wall. So the height from here to here has to be 2 feet because it is the difference between 4 minus 2. So we take that times 2 times the width of 18. And because it is a triangle, we will divide that by 2. Come up with 108 times the 75. That brings us to 8,100 pounds in triangle B. Now, for rectangle C, we have 2 feet on the back wall times 6 feet on the base times your 18 feet width. And it is not a triangle, so we will not divide by 2. 216 times 75. That brings us to 16,200 pounds. Now, we will add the pounds. We come up with 51,300 pounds. Now, to put that into tons, we will divide by 2,000 because there are 2,000 pounds in a ton. And we come up with 25.65 tons.
So this bin is a little bit different than the last bin. This bin actually doesn't hit the wall on the back. It actually goes down to the floor. So it's going to be a little bit different of a measurement and different of a drawing on the paper.
Now to draw this pile, first we'd start with a line at the bottom of our paper indicating the floor. Then we would draw our line on the left side of the paper indicating the back wall of the bin. Now in this particular pile of fertilizer, our shape would look like this.
But we're going to start here again with measuring the distance from the front of the pile to the wall. This is 26 feet.
The length of the pile is 26 feet. That is the distance from the front of the pile to where the pile meets the floor. In this case, right where the back wall met the floor. Next, we measure the width. So we will draw our line out like this to represent a 3D picture.
We're going to measure the width again. That's 18 feet.
This width was 18 feet.
And now our point of references is still the same. We have the black lines on the wall that are about 4 feet tall. And because this kind of cones at the top, we're going to say it hits the wall over there at 4 feet and there at 4 feet. So we've got, it's probably about 9 feet to the peak. So we've got about a 5 feet difference there. So if we imagine this cone here, if we were to smooth it all out, level it out to the walls, it's probably going to be about a third of that. So we're going to envision that being smoothed out is going to be somewhere along this portion of the wall. So we'll measure that. That's going to be roughly about 6 feet. 6 feet will be the height of the peak.
The height of the peak to the floor, indicating with this dotted line, is 6 feet.
Now we're going to measure the peak to the back of the pile. The distance is going to be about 11 feet.
The peak to the point where the fertilizer meets the floor was 11 feet. With 11 feet taken off the total distance of 26 feet, we're left with 15 feet for this distance. We then have our two shapes. We will label this triangle A and this triangle B.
It looks like this particular product is about 60 pounds per cubic foot.
We are now ready to solve. We'll start with triangle A. We will do 15 feet, the base of the triangle, times the height of the triangle is 6 feet, times the width of the triangle, which is 18 feet. And because it is a triangle, we will divide by 2. That would be 810. We will then times that number by the pounds per feet cubed, which in this case is 60. That would then give us 48,600. Now, some people would want to know how many pounds were in their pile, which would be indicated here. Others would like to see it in tons. If they would like to see it in tons, we would then divide by 2,000 because there are 2,000 pounds in a ton. That would be 24.3 tons in triangle A. Next, we will solve for triangle B. We will take the distance from the peak to where the pile meets the floor is 11 times the height of the peak, which is 6, times the width of the pile, which is 18. And because it is a triangle, we will divide that by 2. That is 594. And again, we will take it times 60 because for this particular product, it is 60 pounds per foot cubed. That brings us to 35,640 pounds. Now we will then take that by tons to accumulate what we did here. that would be 17.82 tons. Now we have solved for triangle B, 17.82 tons, and we've solved for triangle A, 24.3 tons. Now we will then simply just add the tons together to get our total for the entire pile of fertilizer. The total is 42.12 tons.
Ashley, watch this.
Charge!
So to start, we will draw our line on the bottom of the paper that will indicate the floor of the pile. Then we will draw a line on the left side of the paper to measure the back wall.
In some cases, the fertilizer may be piled up too high in the bin where you can't climb to the peak of it, just for safety reasons.
Now, because this pile goes up on the wall quite a ways, we will start about here, make our peak, and then come to the floor. Then we will make our three-dimensional lines.
So what you want to do is go ahead and establish your width of your bin, just like you do any other bin. And that bin is 18 feet wide.
And the width of this pile was 18 feet.
Then you want to establish a point of reference for your distance from the front of the pile to the back of the wall. And then you transfer that reference over to an empty bin. So since we determined that about the end of the rafters right here is where that pile stops, we're going to go ahead and measure to the back wall. And that's about 31 feet. So that pile, from the front of the pile to the back of the wall, is about 31 feet.
The distance from the front of the pile to the wall is 31 feet.
You also want to establish points of reference for your height. If you can access the bin, you climb as far as safe up the pile. And we've determined that this pile goes about to the top of the concrete wall. So we'll come over here and we'll look at this empty bin. We're going to go ahead and measure from the ground to where the rafters meet the concrete wall in the back. That's about 16 feet. So we've determined that the peak of that pile is about 16 feet tall.
And our height of the peak was 16 feet.
We'll also make note of a point of reference of a distance of the peak to the back wall, and it appears that this bin, the peak is directly underneath the drag up above. So we're going to come over to this empty bin and stand directly underneath the drag, measure to the back wall, which is about 12 feet.
From the peak to the wall was 12 feet. So we'll bring it down here, make that 12 feet.
Now for the height of the pile on the back wall, we're just going to have to make an estimate. But we're going to estimate that since that pile is so tall, it probably hits the back wall somewhere about right here, which is about 8 feet off the floor.
The height of the pile on the back wall is 8 feet. Now we are ready to draw our shapes. Draw a line here. Now we have a triangle, and a rectangle. This product was 68 pounds per foot cubed. Now we will label this triangle A, this triangle B, and this rectangle C. We will start by solving triangle A. We have the 16 feet for the back height of this triangle. Now this distance was 12 feet, so the remaining distance is 19 feet. 31 minus 12, 19. So we'll times that by 19, times the width of our pile, which is 18. And because it is a triangle, we will divide by 2. We come up with 2,736. Now we will times it by our 68. We come up with 186,048 pounds. Next, we will solve for triangle B. Our distance from the peak to the back wall is 12 feet. So we would take 12 times the remaining height. Our height on the back wall was 8 feet. We have 16 feet of total height, so we have 8 feet left over. So we take that times 8 times the width of our pile of 18. And because it is a triangle, we'll divide by 2. We come up with 864. We will then times by our 68. We come up with 58,752 pounds. Now we will solve for rectangle C. We have 8 feet on the back wall. So we take 8 times 12 times our width of 18. And it is a rectangle, so we will not divide by 2. We get 1,728. We would take that times our 68. We get 117,504 pounds. We will then add these numbers together, come up with 362,304 pounds. Now, if we want to take that to tons, we will divide that by 2,000 pounds, and we will come up with 181.152 tons.
Yeah.
She's on it
Yep.
now. I talked to her earlier,
Good.
and I talked to her.
You know I got next, right?
And she
Yep.
said,
Until that.
as long as everyone.
How many copies would you like?